Alright everyone, today we're gonna learn 4.1 to 4.4, all about power and whatever in between. Work and energy. Work is scientifically measured in joules, not diamonds, not emeralds, none of that. Work, 1 joule of work is done when 1 Newton moves an object 1 meter. So joules equals to newtons times distance, or work equals to force times distance. 1 Newton of energy pushes 1 kg 1 meter, and there you go, that's 1 joule. Energy. Energy is not a thing, it's just a measurement. If a spring is compressed and it has 100 joules of energy, this is a measurement of how much work the spring can do. It's not anything else, it's just a measurement. Forms of energy. Kinetic energy. Energy is a form, energy from motion. All living things have kinetic energy. Anything that moves. Thermal energy. When an object gets hot, particles speed up and gain energy. This is called thermal energy. An example of its use when car burns fuel to produce hot gas that expands and pushes on the pistons. Thermal energy. Radiated energy. The sun emits light in the form of waves. The speaker produces sound in the form of waves. These waves carry energy. So radiated energy is the energy in the waves emitted from something. As you can see, the electromagnetic spectrum, there is the visible light, the ultraviolet, X-rays, gamma rays, infrared radiation, microwaves, radio waves. Radio waves is what we hear. Visible light is what we see. So it's about the same, it's just we can see light while we can hear waves. Alright, potential energy. Gravitational potential energy. Anything that is attracted to something due to gravity has GPE. When a rock is held up in the air and is dropped, it does work because it is attracted to the earth. So GPE is energy due to gravity. Elastic potential energy. When you stretch a rubber band and you compress a spring, they have elastic potential energy. So energy, so EPE is energy when something wants to return to its original shape. Chemical potential energy. When fuel burns, the energy is released by CPE. Fuel, food, and batteries contain CPE. So CPE is energy from chemical reactions. So there's fuel. We can burn it. It releases chemical energy as heat, and then after that, food. We eat that, and we get energy as well. And then, of course, is that Steve? What? Batteries? What are you? No, Steve. No. All right. Electrical potential energy. Things like batteries have ELPE. They supply electricity to something. So ELPE is energy released as electricity. So there's a battery, it has chemical energy, but it releases it as electrical potential energy. Nuclear potential energy. In the center of an atom, there are subparticles held by strong forces. Those subparticles are, of course, neutrons and protons. And if it rearranges or splits, it can release energy. This is nuclear energy. It is also called nuclear fission. So NPE is energy from atoms splitting or rearranging. As you can see, they fire a neutron at uranium, and then it splits, and then energy is released, and then the energy released splits more uranium, and then more energy is released, and it starts a chain reaction. Energy transformation. Conservation of energy. The law of conservation of energy states that energy cannot be made or destroyed. It can only be changed from one form to another. So, as you can see, electricity turns to heat and light. The same amount of electricity is changed into heat and light. None is lost, none is made. It's just transferred to another form. A few more examples. A car engine changes chemical energy to mechanical and heat energy. Thermonuclear reaction changes nuclear energy to radiant and heat energy. A tree changes radiant energy to chemical energy. An electric mixer changes electrical energy to mechanical and heat energy. Hammering a nail changes mechanical energy to deformation and heat energy. A lamp changes electrical energy to radiant and heat energy. Sorry, that was a bit fast. It's just, you get the point. One energy form to another energy form. Wasting energy. It's quite hard to use up all of our energy for a task because it usually gets wasted. When you lift a cup, some energy is wasted as heat. It is almost impossible to be 100% efficient with your energy. A couple more examples of wastage is, for example, when you turn on your car, you can hear sound. You can hear, that sound is useless. We don't want to hear that, but it is wasted through sound energy and other forms of like that, like heat. We don't want heat. We don't care about heat, but it's still wasted into heat. Alright. Joules and transformation. A good thing to know is that work done equals to energy transformed. Work done equals to energy transformed. That's very important. So if a brick is dropped with 20 joules of GPE, it will produce 20 joules of kinetic energy until it hits the ground, and then the energy is transformed into 20 joules of heat. So what this is trying to say, what this complicated sentence is trying to say is 20 joules in one form equals to 20 joules work done equals to 20 joules in another form. So if you punch someone with 20 joules, he will experience 20 joules. Okay? PE and KE. Scalar reminder. Just a reminder that energy is a scalar quantity, meaning that it has a magnitude but no direction. GPE does not care about height, but it does care about height, but it does not care about what path he took to get that height. So here's an example. Here's a little hill, and then oh look, it's a little piggy, and he's climbing all the way up. Look at that, he made it to the top, but it took some while, and as you can see, there's a Herobrine over here. He's a bit of a cheater. He has creative mode, and as you can see, he can just fly right up there and get the same height. If they both weigh the same and the gravity is the same in that universe, it means that they both have the same GPE. It's just that, as you can see, the pig, it took way more to get up there. He actually climbed, while Herobrine over there actually just used creative mode to fly. So definitely not fair, but it's just a scalar quantity, so it doesn't matter. Calculating PE, more specifically gravitational potential energy, downwards force of an object. So equals to the weight of the ball, mg, mass times gravity equals to the weight of the object. If we want to lift the ball, we have to emit the same amount of force pulling it down so we can actually lift it up. So work done in lifting the ball equals to force times distance moved. So the force is the weight of the ball, and the distance moved is the distance moved, mgh. M is mass, gravity, G is gravity, and H is height. Calculating KE. A brick with a mass of 3 kg and has a speed of 3 meters a second. The kinetic energy is half times 3 squared equals to 13.5 joules. That's a bit fast, but kinetic energy equals to half of mass times velocity squared. So mass kg, velocity meters a second, and kinetic energy is in joules. Efficiency and power. Efficiency. When doing something, there will always be energy wasted. The amount that we use up and the amount that was required is not the same. For example, if I want to lift some weights, it will take 500 joules to lift it 1 meter up. This is 50 kg, so 50 kg it weighs 500, and so if I want to lift it 1 meter up, is newtons times distance, so 500 times 1, and that equals to 500 joules. It takes 500 joules to lift it 1 meter up. But in the conversion from chemical energy in your muscles into kinetic energy lifting it up, there is some energy wasted as heat causing us to use more energy. So when we lift it, we lose some energy to heat. Actually, no, we don't lose some energy to heat, we actually lose a lot of energy to heat. Because we actually need something like 3,300 joules because the human body is not very efficient. In fact, it is 15% efficient. The rest of the energy is wasted through either sound or heat or whatever else. There you go, you lift it up. 1 meter. Power. Power is measured in watts. A small engine can do as much work as a big engine, but it takes longer. So a small engine can do as much as that big ass engine, but it just takes longer. A small engine has lower power. Power is the rate at which work is done. So work equals to work. Power equals to work over time, but work equals to force times displacement equals to or distance over time. So power equals to force times distance over time. So distance over time is also speed, also velocity. So force times velocity equals to power. You can use the power equals to force times velocity, or you can use the power equals to work over time, whichever is more convenient to you. I hope you guys get what's going on. Okay, I'm done. Goodbye.